Hello and welcome to Algebra 1 with Miss Andrea. Today we're going to continue on with our lesson in describing data, our unit in describing data. Now, in the online book, this is going to be the 8th module and we are on page 4. So this is lesson 8.4. So Algebra 1, describing data, which means we're getting into statistics. And let's see. So the first thing we're going to get into today is a frequency distribution. So frequency distribution has to do with you're making a chart of all the data, right? So we have, let's see, it looks like 1 is our lowest. And what else is there? It goes up to 5. So we can do 1, 2, 3, 4, and 5. And what we're going to do now is record how many times. How many? Goes over here. How many times do we see each of those numbers? So 1, 1, 2, 2, 2, 2, 2, 3. You could also do it this way. You could write the number 4. I counted 4 3s, so I wrote the number 4. So you can have it as tally marks. You can have it as an actual number, okay? Some people start as tally marks, then redo the frequency table with numbers after they've done the tally marks. It all depends on what is easiest for you and what your teacher is looking for. So for example, if you're filling this out on the computer, I don't think tally marks will work in the computer, but you could do tally marks on your paper. And then when you input it into the computer, you can count up those tally marks and input number 5. Here you go. There is a frequency table here, the score and the frequency. Frequency means how many times does it appear? All right, so now this is a practice for you. I want you to create a frequency table of the number of newspapers sold at a local shop over the past 10 days. So go ahead and pause your video and complete that work. Welcome back. So I have numbers of newspapers and I have frequency, and it looks like 18 is going to be my lowest number. 18, 19, 20, 21, 22, 23, and I'm running out of room because I see a 25 there, 24, and 25. So let's go ahead and count these up. Ooh, very little room there. All right, 18, 1, 2 of those, 19, 0 of those, 20, 1, 2, 3, 4, 21, 0, 22, 1, 2, 23, 1, 24, 0, and 25, 1. So that's your frequency chart. You just count how many times something appears in the data set. This is a box and whisker plot. And as you may remember, we've gone over this before, the interquartile range, IQR, is this area right here between quartile 1 and quartile 3. So it's going to be the center set of data. The highest value is all the way at the end of the box plot. Sometimes you'll see these with lines on the end like this. And this is the lowest value. So this is the minimum. This is the maximum. This right here, this line is the median. And then we have quartile 1 and quartile 3. So remember, those are your 5 numbers, the 5 number set that helps describe the data. So this is a great chart for showing that information. Now, where do all of these numbers fit? That's good. I'm so glad you asked. All 3 of those fit between 2 and 4, right? So those are this red line right here. Then the 4 right here, those fit in this area between 4 and 5, right? Then you have between 5 and 7 right here. And then you have between 7 and 8 right there. So you can see that each one of these covers 1, 2, 3 numbers. So it's each of these, even though they're not spaced, like this block is only 1 number long and this line is 2 numbers long, they each contain 3 numbers. So you can see the more squished up together it is, the more higher concentration of data is going to be just in that one area. Whereas the more spread out it is, you're going to have it that same amount of data over along a bigger spread. Okay, so it's less concentrated. So that is a box and whisker plot. So guess what I have for you? I got some data here. I want you to practice and put this into your own box and whisker plot. So remember, the numbers you need are minimum, maximum, quartile 1, quartile 2, and quartile 3. All right, welcome back. I'm glad you got that done. Now, let's look at this. What's our lowest number? We have to put these in order from least to greatest. I see 26 as my lowest number, 26, 28, and then 29, 30, 31, 32, another 32, and then 35. So I've gotten all my numbers in, and when I create my box plot, it's going to go from 26 to 35. So let's say 25. Let's go to 25 to 35, count every 5. So 25, 30. That's not going to work, counting every 5. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. I'm going to want a straight line here. And then my 26 right there, 35 right there. Now, where is my median? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of these. So there's going to be 5 on each side. 1, 2, 3, 4, 5. So my median's right there between the two 30s, which means my median is 30. So we can go ahead and put a line for quartile 2, which is also known as the median. And then we need to figure out where quartile 1 is. It's going to be right here at 29. Where's quartile 3? It's going to be right here at 32. I picked the number in between the middle of the upper half of the data. So number 32 is right in the middle of 30, 31, 32, and 35. So 29 was my quartile 2, and 32 was my quartile 3. So now I need to connect these into a box and then throw some whiskers on it. There we go. So that is my box and whisker plot for number one set of data. What color should we use for the next one? Let's go with orange. I like orange. Okay, we have to first arrange this data in order from least to greatest. So I'm going to start with 26 and then 29 and then 31, 32, 33, 35, 37, 38, 41, and 48. So my lowest is 26, my highest is 48. Let's count by twos. 26. I don't know if I'm gonna have enough room. Let me put this a little bit lower. 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. All right. Now create a line across the bottom. That's just to mark our numbers. And I'm going to go ahead and put a line at my lowest, which is 26, and a line at my highest, which was 48. All right, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 again. So 1, 2, 3, 4, 5. Here between 33 and 35 is my median. So since they're not the same number, I need to add them together and divide by 2. And when I do that, I get 34. So here's my quartile 2, or my median. And 1, 2, so this right here is going to be 31 is my quartile 1, and 38 is my quartile 3. So where's 31 here? It's right here. So we've got 31, and then 38 is right here. So let's connect these. And then draw some whiskers. And there you go. There is my box and whisker plot. And my interquartile range is from 31 to 38. So 38 minus 31 is 7. So my IQR, I can easily see, is 7. That's the interquartile range. But what is my range? My range is 48 minus 26. So it's going to be 22. So you can see a lot of good data using the box and whisker plot. All right, let's move on to this last one. Put this in order. It looks like my lowest number is 34. Yep, 34. Let's go with 37, 38, and 39. 41 and 42, 43, 44, 45, and 48. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So right there, so 41.5 is my median. 38 is my quartile 1, 44 is my quartile 3. So I'm going to need some line that's between 34 and 48, so about 14 long. Let's see if we can do that. 34, 35, 36, 37, 38, 39, 41. All right, there we go. Looking good, looking good. Let's throw a line across the bottom of it all. 41.5 is right here. 38 is right here. 34, our lowest or minimum value, is right there. 48 is our maximum value. 44 was our quartile 3. So now I'm going to connect all of our interquartile range here, and then throw some whiskers out to the minimum and maximum. All right, so those are your box and whisker plot for the data that you have. Numbers 1, 2, and 3. All right, so we've got another one to look at. We've got a dot plot. Now, what is a dot plot? A dot plot, here we have a frequency table. It says that what percent of a population of a country to the nearest 10% has access to electricity. And so they've gone through, and there's 5 countries where 10% of the population have access to electricity. 6 countries have 20%, 12 countries have 30%, 5 countries have 40%, 4, etc. So how do we create a dot plot? Well, we're going to put all of these numbers across the bottom, that bottom line that we had before. And then you're going to put over the number 10, 5 dots. Then over the number 20, 6 dots. Let's see what this looks like. Here you go. So 10% of the population with access to electricity, there's 1, 2, 3, 4, 5 countries. 20%, 1, 2, 3, 4, 5, 6 countries. Except, so 50%, there's 1, 2, 3, 4 countries. So this is just a visual representation of this frequency table that you can easily look at and see. It's easy to tell this has way more countries have 100% than do countries with 50%, say. So it's easy to tell. Now, this that you're looking at is what we would call bimodal, because there are 2 peaks in it, right? We have a peak here and a peak here. So this is a bimodal representation. All right, histogram. Each month you measure how much weight your puppy, your dog, your pet has gained, and here's the results. So in order to create a histogram, remember they're very much like bar graphs, except there's no space in between the bars. But in addition to that, so across the bottom, you're going to say the numbers, like you're going to have negative 0.02, you're going to have 0, you're going to have 0.1. You're going to go in order with each of these amounts. And then on the side, it's going to be your frequency. So how many times do you have 0.2? Only 1 time. How many times do you have 0? Only 1 time. How many times do you have 0.1? Well, you've got that twice. So that bar will be twice as big as your previous 2 bars. Let's see if I have, there you go. So between 0.5 and 0, that means that this dog gained weight 1 time between 0.5 and 0. And then from 0 to 0.5, so they counted their data between 0 for every half of an ounce. So all the 0.3s, the 0.4, all of those are included in here. And there were 5 instances of those. And you notice there was 3 instances of half an ounce to a full ounce, right? But there was no changes between 1 and 1.5. I know you're looking at that going, Miss Andrea, you said there's no spaces. Well, there's not. This is what is showing us that there are 0. So between 1 and 1.5, there's no space here between this bar and this bar. This is another set of data. It just so happens that we have 0 pieces of data that fall into that category. And that's why there is not a bar there, okay? So we're to make a histogram for each set of data. All right. First, we need to order it. That's always the first step. So we're going to do 80, 81, 82, 84. Those are all 9s. 88, 89. 92, 93, 93, 96, 97, and 99. All right, So looking at this, we need to determine what our categories or groupings of numbers are going to be. So it goes from 80 to 99. So about 20, because we could say 80 to 100 pretty easily, 20. So let's break it up into groups of 5. Now I don't think I'm going to have enough room to leave the histogram up on the table in between each rendering. So let's start with 80 and let's go to 100. Ooh. All right, so that's 20. So halfway in between would be 90. And then this would be 85. And then we'll put what this is 95. And then draw one up this way. And we'll say this, of course, is 0, 1, 2, 3, 4, 5. All right. So between 80 and 85, there's 1, 2, 3, 4 pieces of data. So that means we're going to go up to the 4 and go over. And then we can color that in if we so desire. And then between 85 and 90 is going to be 2 pieces of data. So that's going to go about right there. And then between 92 and 95 is 3 pieces of data. Now, I did not do a very good job of drawing this, it looks like, because every bar is supposed to be equally as thick, and it looks like this one's much thicker than this one. But you're supposed to, if you have graph paper, make them the same amount of thickness, 96, 97, and 99. So our last one is 3 as well. So here is what your histogram would look like for number 1. I'll leave that up for just a moment while I am putting these in order. So we're going to have 82, 84. I should choose a different color. Let's go with green. 82, 84. Oh, we missed an 83. 83, 84. And then I think 2 86s. And then 87. 91, 91, 92, 92, 93, and 97. All right, so I'm going to keep the same base information between 80 and 100 and 1 and 5. And let's look at this. Between 80 and 85 is right there, between 85 and 90, and then between 90 and 95, and then between 95 and 100. Okay, so now let's look at this data. There's 4 for this first one. 4. I'm actually going to scooch this. Oh, did not mean to do that. There we go. I'm going to scooch this just a little bit. 90. There we go. All right, so how many did we have here? 1, 2, 3 in that one, so 3. Then in the next one, 1, 2, 3, 4, 5. So that one is all the way up there. I didn't do a good job of going all the way up there, I'm sorry. And then 95 to 100 is just 1. So that is our histogram for number 2. So I'm going to leave that up for just a minute while we order number 3. And let's see, it looks like it starts with 81, 83, there's all my 80s. There's an 89. Wow, okay. Moving on, 91, 92, 94, 95, 2 of them, 2 97s, and 2 98s. All right, my data is very squished together here at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, we got the correct amount of data. So let's go ahead and get started drawing this histogram. Oops. Let's first see how many is in each set. I'm going to keep the same set. Looks like 2 in the first set, 1 in the second set. '90 to 95 is 1, 2, 3, 4, 5. 90 to 95. Those actually should go right there. 95 should be included in the higher one. So let's erase that line. Then 95, 1, 2, 3, 4, 5, 6. So we're going to have to draw one more line up there. All right. So the first one is 2. Second one was 1. Third one was 3. And the last one was 6. There you go. There is your final histogram for data set 3. All right, skew. Now, this is what we call a normal distribution, also known as a bell curve or a Gaussian distribution. And when you have this one, your mean and your median are going to be the same number right here in the middle. It's a perfect center of data because everything on a normal distribution is going to be symmetrical. That means this right half is exactly the same as this left half. If you were to fold it in half at the median, these would lie on top of each other just perfectly. Okay, so there is no skew in a normal distribution. Now, what does skew look like? It looks like this one right here. This is considered a left skewed. If you notice, most of the data is going to the right, and this is what we call a tail. This tail is to the left. So the tail being to the left is left skewed. To me, this is named opposite of what I want to call it. I would want to call this right skewed. So you need to figure out a way to remember which one is which. This is left skewed when the tail is to the left. So always pay attention to where the tail is, not the most of the data. It is a left skewed. And what that means is the mean is not necessarily going to be the best center of data. You're going to have the mean, the median, and the mode. If you notice, the mean is to the left of the median. All right, now here's a right skewed, and the mean is to the right of the median in this one. So the median is directly in the middle, remember? And the mean means the average of all the data, right? The mode is the number that appears the most. So that's going to be at the highest point. The mode is always at the highest point. So where's the mode over here? It's the same place as the mean and the median. The mean, the median, and the mode are all in the same spot on a normal distribution. When you have a left or a right skewed distribution, the highest point is where the mode is. And then the median comes next in between them. And then the mean is the smallest line or indicator of data. So the best center of data to judge a center of data, to measure the center of data on a skew chart would be the median. All right, so we've got some practice here for us. We're supposed to find the mean, the median, and the mean standard deviation of the data and create a dot plot. Okay, so let's write down what we're supposed to find first. The mean, the median, and the mean standard deviation of the data and create a dot plot. And we're supposed to tell if there's any skew. All right, so let's order this data. We've got 2, 3, 4, 5, 5, 5, 5, 6, 6, 7, 7, 7, 7, 8, and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 pieces of data. I'm going to write that down and circle it so I know it's not a part of the data set, but it's important for me to know how many pieces of data there are when I'm doing the mean, because that's the first piece of data that I'm asked for. So I'm going to figure that out now. How do we find the mean? It's just the average. So we're going to add everything up. 2 plus 3 plus 4 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 7 plus 7 plus 7 plus 7 plus 8 plus 13, enter, divided by 15. All right, so the mean of the data, which remember you write with an X bar, is 15. Yep, sorry, not 15. That's how many we divided by. It's 6. All right, so now we need the median. The median is in the center of the data. So we can't really divide 15 in half, so 14 in half is 7. So it's going to be the 8th piece of data is our median. 1, 2, 3, 4, 5, 6, 7. It should be 6. Let's make sure we have 7 on the other side. 1, 2, 3, 4, 5, 6, 7. So our median is also 6. I'm guessing, because these are the exact same number, that this is going to be normal distribution, meaning there's not going to be any skew at all. Okay. All right. So our mean standard deviation. Now we're going to take and subtract 6 from each of these numbers. I'm going to switch to a different color. So 6 minus 2 is 4. 6 minus 3 is 3. 6 minus 4 is 2. 1, 1, 1, 1, 0, 0. 1, 1, 1, 1, 8 minus 6 is 2, and 13 minus 6 is 7. Now we have to mean those differences. All right, 4 plus 3 plus 2 plus 1 plus 1 plus 1 plus 1 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 2 plus 7, enter, divided by 15. 1.73 repeating. Okay, now on to the final step. We need to create a dot plot. So this goes between 2 and 13. Oh boy, I need to go back to my straight line drawing. Here we go. So much better. All right, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. It's a little more scrunched together towards the end than at the beginning. Sorry about that, folks. All right, so we've got 2. There's one of those. There's 1, 3. There's 1, 4. How many 5s are there? There's 1, 2, 3, 4 5s. 2 6s, 1 2 3 4 7s, 1 8, and 1 13. Ooh, they should ask if there was an outlier. Doesn't that look like 13 is an outlier? It certainly does. And this is more a bimodal because there's 2 peaks in it than it is a normal. So it's not normal, it's bimodal, but there is a little bit of skew to the left. This would be more like a left skew because the data is more concentrated to the right. But then again, because of that 13 over there, if you were to draw a line over this, it might even be more skewed to the other side. So let's see. Data. All right, practice. Give 5-number summary. Remember, the 5-number summary is the minimum, quartile 1, median, quartile 2, and the max. And we're supposed to create a box and whisker plot for this data. Oh boy, I remember box and whisker plots. We've done several of those already. So we've got, oh, these are already in order. Praise the Lord. Thank you. 1, 2, 3, 4, 5, 10, 15, 16 pieces of data. So that means that there's going to be 8 on each side. 1, 2, 3, 4, 5, 6, 7, 8. Right there is the median. 1, 2, 3, 4, 5, 6, 7, 8. So halfway between 31.1 plus 1, 31.1 plus 31.5, enter divided by 2 is going to be 31.3. So let's go ahead and put quartile 1, quartile 2, quartile 3, and quartile 4. This is going to be 31.3. 31.3. All right, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4 right here is quartile 1. So 27.6 plus 28.9 divided by, well, no, not divided by yet. I have to enter first and then divide by 2. 28.25. And then quartile 3, 1, 2, 3, 4. 1, 2, 3, 4. That one's easy since there's 34 on both sides. It's just 34. And it's not really quartile 4. It's quartile 1, quartile 3. This is the maximum, is what we need. Max is 45. Minimum, we didn't write up here, minimum is 26. Quartile 1, quartile 2 is also known as the median. So did we cover all their information? Minimum, quartile 1, median, quartile 2. Oh, that's supposed to say quartile 3, not quartile 2. Sorry about that, folks. Quartile 3, and max. So we do have all of their information. Now we need to create our box and whisker plot. And so this is going to go from 26 to 45. So let's see, 26 to 45 is about 20 pieces of information. Let's go by twos. 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46. All righty, now we can get to drawing. Our minimum is 26. Our maximum is 45. Our median is 31.3. That looks like it's about 31.3, doesn't it? And then quartile 1 is 28.25. So right about there. And quartile 3 is 34 exactly. So right there. So now let's connect these to create our box. And then throw on some whiskers. Where is this data concentrated? It's concentrated right here in the center in the box plot, our interquartile range. You can tell that there's a lot more data just in this little section than there is in this section. And then of course, this whisker has more data than this whisker does, concentrated, all bunched up together than the one that's spread out a little further. All right, so here we're supposed to tell the interquartile range as well as the range. So it says tell the range, the interquartile range, and create a histogram of the following data and tell if there's any skew. All righty, so we need to put these in order from least to greatest. So, because that's going to be the way to tell the interquartile range. So we've got 5. This is the average lifespan, 5. I don't see any other single digits. So we're going to move on to 10, 10, 10, 10. Looks like they all are pretty good numbers. 11. Any more teens? 14. 2 15s. An 18. A couple of 20s. Wow, okay, so it jumps to 27. And then from there, it's going to jump to 35. And then 2 40s. Oops, 40 and 40, and then a 50. All right. I believe that's all of our data. Let's count it just to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, all the data. And our median is going to be right here in between. We've got 8 on one side and 8 on the other. So halfway between there, 15 plus 18 entered divided by 2 is 16.5. Actually, we didn't even need to know that to find the IQR. We just need, remember IQR is quartile 3 minus quartile 1. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 10.5 for quartile 1, 10.5. 1, 2, 3, 4. So right here between 27 and 35. 27 plus 35 enter divided by 2 is 31. So 31 minus 10.5 is 20.5. So IQR is 20.5. So we got that done. It also asks us for range. So let's figure that out. What is our range? You take the highest number 50 minus 5. So it's going to be 45. The max minus the minimum. So we got range and IQR. So the only thing left to do is to create a histogram. Ah, man, I need my straight line again. All right, let's go by tens. So we'll go 0, 10, 20, 30, 40, 50. Let's see. 1, 2, 3, 4, 5. I don't know if there's going to be more than 5. Let's see. All right, I'm going to go and choose a different number. So 0 to 10 is going to be 1. 10 to 20 is going to be a lot. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8. 8. There's 1 there. 1, 2, 20 to 30 is 2. 30 to 20 to 30 is not 2. I forgot 27. I don't know how I missed that, but that should be 3. Then 30 to 40 is 1, and 40 to 50 is 3. 8, 5, 6, 7, 8. All right. So let's create this chart. The first one is 1. That wasn't a very good straight line. The second one was 8. So this is where we need to draw all the way up. And then the next one was 3. Right about here. And then our next one was 1 again. You know what? I don't remember on the last one seeing if there was any skew. Okay, so if I were to say that this had skew, I would say that this is a right skewed histogram because the highest peak is over here on the left, which means the tail is kind of over to the right. So it is a right skewed because the tail is to the right, because the maximum, the highest peak appears right here at the very beginning on the left. So this is a right skewed chart. Ooh, and that was our last practice problem. All right, so we'll be back to look at some more charts in the next lesson.